Hello everyone. Today we are going to discuss very important topic in the circuit analysis or circuit theory. It's a nodal analysis. In the previous class, we discussed about the mesh analysis. We used Kirchhoff's voltage law to writing the loop equations. Now today we are going to discuss about another method, the nodal analysis. It is also one of the important technique to solve the networks. In this nodal analysis also we will follow the steps as similar with the mesh analysis. In the mesh analysis we identification of meshes is the first step. Here in the nodal analysis also the first step is the identification of nodes. Okay, right. Let write down the steps to follow the nodal analysis. The first step, identification of nodes. First of all, what is a node? Node is nothing but a junction where two or more branches joining together. If the two branches are joining to a one point, that point is nothing but a node. So here, for example, if this one resistor and this is also a resistor connected to this point is nothing but a node or a junction. Okay, so when you're solving the problems, it is very easy to identification of nodes, and we have to exclude the reference node. So we have to identify the reference node also, and when you're writing nodal analysis, we just exclude those reference node, and we have to write down the nodal equations for the remaining nodes. Okay, so the first point is identification of nodes, and the second point is write down the nodal equations at each node. So writing of nodal equations at each node. So we use KCL here. So in the mesh analysis, to write the mesh equations, we use Kirchhoff's voltage law. But in this nodal analysis, we use Kirchhoff's current law. And we have to use the identification of currents also. So I think it is the step number 3, and step number 2, assume the current directions at each node. So we have to assume the current direction at each node, whether it is towards the node or away from the node. So that is step number 2, and step number 3. So we have to write down the nodal equations at each node by using Kirchhoff's current law. And fourth step is solve those nodal equations. So whatever we written the nodal equations, we have to solve those nodal equations, and we can calculate the node voltages. So what we calculate? Node voltages. Node voltages. In the mesh analysis, we calculated I1 and I2, that is loop currents. Here we calculate the node voltages. Okay, these are the steps we can follow by using the nodal analysis. So start with a simple example to identification of nodes and solving those nodal equations. Okay, so question number 1. So simple problem I can give here. Find the current through 6 ohms resistor using nodal analysis. Okay, the question is like this: voltage source composed 10 volts, one resistor 2 ohms, 5 ohms, and this will be 6 ohms. And here 1 voltage source here. So that will be 5 volts. So that is the question they given. We have to calculate the current flowing through this 6 ohms resistor. So we have to calculate I, the current flowing through 6 ohms resistor. That is the point. So coming to process, step number 1. Step number 1, identification of nodes. So how many nodes are there? So if you see this 10 volts battery source and these 2 ohms are connected at this point. So that is first node, and these 3 resistors are connected at this point, and this will be node number 2, and this 6 ohms and this 5 volts are connected at this point, and this will be node number 3. So this will be a ground connected to ground. These are called a zeroth node or reference node. So how many nodes are there? Total 3 nodes. So for identification, for easy to identification process, the number of nodes is equal to the number of nodal equations. In the previous case, the number of loops or number of meshes is equal to the number of mesh equations. Okay, right. Step number 1 is completed. So by excluding reference, we have total 3 nodes. Step number 2, assume the current directions at each node. So at this node, the current directions, so the 10 volt source will give this direction, the current in this direction, and I assume at node 2 all currents are leaving in this direction. So all currents are leaving at node 2. So one current is from node 2 to node 1, and one current is from node 2 to the reference, and one more current is from node 2 to node 3. So it's my assumption. So I always assume, this is also a notation. We can assume any direction. So you can assume one current towards the nodes also, but follow this notation. So it is easy to, you can apply the same procedure for any number of times in any network. So I assume all the currents are leaving at the node. And coming to node 3 also, the current is flowing in this way from 5 volts battery. So done. Step number 2 is done. Next, step number 3. Step number 3. Write down the nodal equations at each node. So nodal equations, to write the nodal equations, first of all you have to identify the nodes and each node having some voltage. So at node 1 we have node voltage V1, at node 2 we have node voltage V2, and at each third node we have voltage V3. So at node 1, so at each node we have to write nodal equations by using KCL. So at node 1, so we have to write only one voltage source V1. So that V1 is nothing but 10 volts. So at node 1, what is the voltage V1? That will be equal to 10 volts. That is V1 equal to 10 volts. So that is equation number 1. And at node 3, so I will first write node 3, it is for easy. And at node 3 voltage is V3. That V3 is nothing but it is connected to 5 volts. That is V3 is equal to 5 volts. That is equation number 2 I can write. And at node 3, it is very careful at node 2. At node 2, so we have to write voltage across V2. So voltage at node 2 V is V2. So if you observe here at node 2, how many currents are leaving? 3 currents are leaving. So according to the KCL, the sum of the currents entering at node is equal to the sum of the currents leaving. So what is the currents entering into the node 2? So from my assumption, entering is equal to 0, right? Entering current is equal to 0. So what are the currents leaving? So V2 to V1 one current, V2 to reference is one current, and V2 to V3 is another current. So from the current leaving from V2 to V1, it is nothing but V2 minus V1 upon 2 ohms, right? V by R is nothing but a current. So that I have to write the current from V2 to V1, I is equal to V by R. So the potential difference is V2 minus V1. So V2 minus V1 by 2 plus, why? Because algebraic sum of the currents entering is equal to the algebraic sum of the currents at the node is equal to the algebraic sum of the currents leaving at the node. So from V2 to reference node, that is V2 minus 0 by 5 ohms plus, and V2 to V3. So V2 minus V3 upon 6 ohms equal to 0, that is at node 2. That is equation number 3. So by solving 1, 2 and 3 equations, we can get V1, V2 and V3 values. V1, V2, V3 values. So we already know V1 and V3 is 10 volts and 5 volts. From node 2 equation, substitute V1 and V3 in equation number 3 and we can get V2 value. The problem is not over at here. So what is the point they want? Find the current through 6 ohms. So they want the current through 6 ohms. So the current through 6 ohms is nothing but V2 minus V3 by, so I across 6 ohms is equal to V2 minus V3 by 6 ohms. So we have to calculate the current through 6 ohms resistor by using this formula. So from these three equations we can calculate V2 and V3. So V2 minus V3 by 6, if you are writing like this, we can calculate current through 6 ohms. In this way we can calculate the current or voltages across any branch in the network. Okay, let's do another problem to understanding better. Okay, right. Calculate the current through 2 ohms resistor using nodal analysis. The question is like this. It is 1 ohm in series with the voltage source 20 volts. It is again 20 volts. It is 1 ohm. This will be 2 ohms. 1 ohm. It is 0.5 ohms. Yes, they give voltage as a reference. So they want the current through 2 ohms. Okay, that will be treated as some current I. Okay, we'll solve this problem with nodal analysis. So I can replace this network with a simple manner. So for our identification purpose, so we can represent this network is in this way also, right? So this will be 1 ohm, 20 volts, 1 ohm, 0.5 or 0.5 is 0.5 ohms, and it will be 2 ohms, 1 ohm and 20 volts. Okay, step number 1. How many nodes are there? So these two are connected here, this branch is also connected here, that will be node 1, voltage across node 1 will be V1. So this 1 ohm is also connected here, so here it is also node 1. So why? Because it's just a wire, so I can take it as a single node. So here at also this point is also having node voltage V1, and this point is V2, this point is V2, and this point is also same, it's just a single wire, there is no element is connected between, so this voltage is also nothing but a V2, right? So that is the identification, and this is a reference node. So how many nodes are there? Two nodes excluding the reference. Step number 2, what is step number 2? Identification of current. So current directions, current directions, so I can give current directions like this. At this node in this way, so there is no current flowing here, and in this way at node 1. And coming to node 2, this is one current direction, this is one more current direction, and this is another. So I always choose the current leaving the nodes. Okay, so the sum of the entering currents is equal to 0, 0 equal to sum of the currents leaving. So for that purpose I assume that all currents are leaving the nodes. I hope you also follow the same notations. Okay, done. So step number 2 is done. Coming to step number 3, nodal equations. So at node 1, if you see at node 1, how many currents are leaving? Two currents. So sum of the entering currents is equal to 0. So two currents are leaving. One is from V1 to 20 volts. Another current is from V1 to reference. V1 to reference. So current direction 1 is V1 minus 20 upon 1 ohm. So why? Because the potential difference from V1 to 20 volts. So V1 is at node 1, I assume that V1 is the higher potential. So V1 minus 20 by 1 ohm plus what is another current? V1 minus reference node V1 minus 0 upon 1 ohm. So these are the two currents leaving. So from this I can write, so from this 2V1 equal to 20, V1 equal to 10 volts. This is equation number 1. No, at this node we have to follow this current also. So V1 to V2, V1 to V2. So there are 3 currents are flowing from this node. So further we have to write one more current leaving from V1 to V2, that is V1 minus V2 upon 0.5 ohms. So this is wrong. So when you are doing mistakes, then only we can understand better. Okay, so when you are practicing the problems, then you will be masters. So what we forgot? So here the one more current is flowing from V1 to V2 also, from V1 to V2. So we forgot this current. So now we added this current is also. So from this I can write 4V1 minus 2V2 equal to 20. This is equation number 1. Next, at node 2, how many currents are there? 3 currents are leaving. So sum of the currents entering is equal to 0. So what are the current leaving? V2 minus V1. So V2, from V2 to V1, one current, that is V2 minus V1 by 0.5 plus V2 minus 0 by 2 plus V2 minus 20 divided by 1 ohm. Okay, so these are the currents leaving from node 2. So I can further simplify this node 2 equation as I am writing here. That will be minus 2V1 plus 3.5 V2 equal to 20. So this is equation number 1, right? Equation number 2, right? So solving 1 and 2. Solving equation number 1 and equation number 2. So I can write here 4V1 minus 2V2 equal to 20 and minus 2V1 plus 3.5 V2 equal to 20. By solving these two, so I think we have to multiply it with 2 times. So this will be cancelled and it is 7, that is 5V2 is equal to 60, right? So this is 40 plus 20, 60. It is 7 minus 2, it is 5. So V2 equal to 12 volts. And substitute V2 in equation number 1, I can get V1 as it is 11 volts. So these are the parameters I calculated from nodal equations. The problem is not yet over. The question is, we have to calculate the current flowing through, what's the given? The current 2 ohm resistor. So where is the 2 ohm resistor? Here. It is the 2 ohms resistor, the current flowing to 2 ohm resistor. So the current flowing through 2 ohms resistor is equal to, so V2 minus 0 by 2 ohms, right? So I calculated V2 as 12 volts upon 2 amperes, 2 ohms, it is 6 amperes. I 6 ohms. The current through 6 ohms is 6 amperes. This is the final answer. So in this way we can solve any type of problems. Okay. So when you are writing nodal equations at node 1 and node 2, it is very important to identification of currents. So if you able to write the nodal equations, 90% job is completed. The rest is mathematics. Okay. So in this way we can solve many problems by using nodal analysis. I hope you enjoyed the session. So if you like it, like the button. If you have any queries or any doubts, please mention in the comment box. I will definitely reply. If it is useful, share this video and please subscribe to the channel. Thank you. Have a nice day.